Right, so I'm going to do another video on conservation of momentum. It's very simple, but just might require a little bit of practice. So I'm going to give you several examples. So the first one I'm going to just keep talking about cars, and yes, I can draw cars better than that, but this is physics, not art, so I'm just going to do it in a very basic way. So this is car 1. And this is car 2. I'm going to say this is 2 kilograms, this is 3 kilograms, and this is 10 meters per second. Okay, so this is my before scenario. I have 2 cars. One is stationary, that's 3 kilograms, and the first one is 2 kilograms and it's moving towards the second one with a speed, or rather with a velocity of 10 meters per second. Okay, now what's going to happen in this scenario is once they've collided, they're going to basically be stuck together. I don't mean literally stuck together like with glue, but they are touching, they are in contact with each other. Okay, so I know that this one is 2 kilograms and this one is 3 kilograms. You would be asked to work out possibly the speed of my 2 cars together after the collision. Now, conservation of momentum means momentum is conserved. So the amount of momentum there is before is going to equal the amount of momentum afterwards. Okay, so before, remembering P equals mv, it's going to be 2 times 10 momentum of car 1 plus momentum of car 2, 3 times, it's stationary, 0. Okay, that's going to give me 20 plus 0, so 20 kilogram meters per second. Okay, now I know then that the momentum here in this scenario after the collision also has to be 20. So because they're stuck together, I can consider them to be basically one vehicle now. So I'm going to add those together, remembering P equals mv. So 2 plus 3 times v, that's my momentum of this situation, I don't know what v is, must equal 20. So 20, I should really put the units, but I don't have much space. There we go. So 5v equals 20. What's the velocity? 20 divided by 5, that must be 4 meters per second. And that's your first example.